I'm Kathryn Sizemore. I'm a solutions architect at MariaDB. In this demo, I'll show off how you can achieve high availability with MaxScale. Hopefully you've heard of MaxScale. It's really a Swiss Army knife of tools in a very, very simple layer, primarily for load balancing and automatic failover management. So today I'm going to go over how to eliminate that single point of failure with 2 MaxScale nodes and how that works in our highly available architecture. So for our demo, I've set up three database servers in the US West 2 region. Here's the nodes 1, 2, 3. MariaDB 1 is currently in my primary, and 2 and 3 are replicas. I have both MaxScale nodes in this region as well. You can see that I've spread them out across different availability zones. 2A is my primary, 2B and C, and I've separated my MaxScale nodes between availability zones as well. I've also spun up a 4th node of MariaDB in the Ohio US East 2 region. And I'll use this to primarily show DR and how that could be used. Obviously, architectures for DR can get vastly more complicated, but this will be a very simple demonstration that you can build upon. Now, to connect to these MaxScale nodes, typically you'll have the application layer, and I've developed a very, very simple Java code. You can see it has MaxScale 1's IP address and MaxScale 2's IP address, and I'm using the JDBC connector from MariaDB in a sequential method. So what that means is that it will go to the first URL in the sequence, and until that URL is no longer accessible, until it gets a failed connection, it will continue to use that first node. Once it does get that failed connection, it will start using the second IP address in the line. So you can see on our documentation here for MariaDB connector J, I have multiple different modes. What I'm describing here and using in the demo is sequential, and it will just say write to that first node. If first node goes down, it starts writing to node 2. You can also do a load balancing method that distributes those IP calls evenly. This is definitely possible with this new cooperative locking of MaxScale. Both MaxScales can both read and write and have no performance issue. So what this little script is going to do here to demonstrate that connection string, it will just connect to the database. It will make sure that the table I need is there in the database. It will insert a record that says my MariaDB server ID to tell you which server it was written with, and then a timestamp, which will come from the defaults. It will read back to me that primary key, the source database it came from, the timestamp it was entered with, and then which read source it's pulling from. What's the server ID that it's now pulling from? Because part of this demo is showing read-write split, and that with MaxScale, you can easily separate your reads and writes and balance that load across those multiple replica servers. All right, so let's run it. Here you can see I've printed out that sequential connection. Obviously, you won't want to do this on your own since I'm printing out the password, but I wanted to show that it's just very simple, the sequential connection string with the primary and secondary IP addresses. Here I ran this script a few times prior to this video. You can see the timestamps increase. And so far, I'm writing entirely from MariaDB 1. So in my diagram here, it's connecting to that first MaxScale node because it hasn't run into any issues with our sequential connector. And it's going straight through to the primary, writing to the primary. And then you can see my read is coming from MariaDB 2. So when it goes back for that call of what is in that table, It's pulling from that MariaDB2 replica node. So now let's go into how MaxScale automatically fails over when a primary node goes down. Here I have MaxScale 1 on the left and MaxScale 2 on the right. This is the command max control list servers being run under watch every 1 second. So we're seeing relatively up-to-date status checks on what MaxScale is seeing and what it's doing. And then down below here is MaxScale log. I'm just tailing the log on both so we can see what is actually happening with MaxScale and the decision it's making behind the scenes. So then the other really useful tool that I want to show you is the MaxScale GUI interface. Here is the IP address for MaxScale 2, and then the port for that by default is 8989. So if I go to that address, I come up, I get the welcome page. The default login is admin and password is MariaDB. And then you can obviously change that as soon as you install it, and definitely in production you definitely want to do that. That user interface, it's got a very pretty version of what I was seeing with the max control list servers. What's also nice is I can hover over the state and it will give me a little bit more information. You can see that MariaDB1 node is the master, but you can also see that it has 3 replicas and they are 0 seconds behind master, all 3 of them. Same thing with going into the slaves. It gives you a little bit of a rundown on the replication status on that node. So let's try to break some stuff and kind of leave these as dashboard indicators of what's going on behind the scenes while we do that. So let's start with the basics. We will shut down MariaDB1, which is currently primary, which is equivalent of just pulling the plug. There's no graceful shutdown or anything, and see how MaxScale handles that. Let's stop that instance. You can see not all my interfaces showed the same thing simultaneously, but that's just a delay in their refresh rate. But it did detect that down for MariaDB1 fairly quickly. You can see MaxScale 1 is got that cooperative block, which we'll talk about in a little bit. It failed over from MariaDB1 to MariaDB2 and gave it a new master status. So we see that MariaDB2 is now the new master while MariaDB1 is down. Now, if we scroll back up in this log a little bit, we can see that right after the monitor was unable to detect MariaDB1 anymore, and it registered it as master down, we get this warning here that master has failed. If master does not return in 4 monitor ticks, failover begins, right? That monitor ticks can be configured so that you can failover faster. This is just the default that I've got set here. Let's say my network outage or crash of MariaDB back on, I'm able to resolve it and it comes back online. Now you can see already, as soon as it detected that it was back online, and it probably took a few seconds to start and get MariaDB back running, MaxScale directed it to replicate from MariaDB2. So it made it a slave of MariaDB2 so that it's not trying to be a conflicting master. We can see that MariaDB1 is a replica of MariaDB2, and it's 0 seconds behind the master. So let's go back to that script and see what it says now. So here it's now writing to MariaDB2, our current master, and now that MariaDB1 is back online, it is a replica node, and so we are reading all of these records from MariaDB1 instead of from MariaDB2. Some of our read-write split there in action. So taking a moment to go back to our diagram. When that MariaDB1 primary node went down, MaxScale identified that failure. and promoted that MariaDB 2 replica to be a new primary node. As soon as MariaDB 1 was back online, MaxScale instructed MariaDB 1 to be a replica of MariaDB 2 and started routing those reads to MariaDB 1 once it was in sync. Next, let's demonstrate what happens when a whole region goes offline. Here I've added our disaster recovery DR node, or MariaDB 4. Remember, this is the node that I spun up in a different region, the US East 2 region, specifically the 2A. The rest of our servers in this demo are in the US West 2 region, with each MariaDB node in a separate availability zone. For this demo, you'll note that I have both the MaxScale nodes in the same US West 2 region. MaxScale 1 is in US West 2A, and MaxScale 2 is in US West 2B. But in production, you'll want at least one MaxScale node in your DR region as well. So be sure to choose a complete DR architecture that fully meets your HA and RTO requirements. So let's shut down all 3 MariaDB nodes in the primary region and watch MaxScale promote that DR replica in the US East 2 region with no downtime. Remember, I have MariaDB 4 over here as my DR. So I'm going to take the entire Oregon MariaDB site offline. Immediately, all my primaries are shown as down in that Oregon region. And it's determined that MariaDB 4 should be the new master, as it's the only one standing. And here we have it running as a new master. All right, let's bring those nodes back online. Oh, now it says it's running, so it'll take a few seconds to bring up that MariaDB. All right, we're starting to see that they're available, and they are slaves already of that master node. If we go over here to our GUI interface, we can see it's running, and all 3 are replicas of MariaDB 4. Perfect, exactly what we want to see. Okay, while we're in this state, let's go back to our Java demo and see where it's writing to. And you can see here, it's successfully writing to MariaDB 4, even though I have those slaves back online. And it's reading from MariaDB 1, which is a replica node. All right, now we don't want to have to shut whole servers or stop MariaDB on these instances to move the master around, right? Sometimes we want to set that master specifically. Like in this scenario, I want to move that master back to MariaDB 1. I don't want it in the Ohio US East 2 region now that I've brought my Oregon US West 2 region back online, my primary region, right? I have a little command that we can run on the MaxScale server. So this is connected to MaxScale 1. And this is my template for the instruction of the call, right? This is just a simple API call. So it's max control, call command, MariaDB mon, which is one of our monitor modules, switch over, do the failover. I'm going to put in my database monitor, which is down here. I've named my monitor of these instances as mdb_mon. Monitor. And then the new master, I want to switch back to that original primary node, which was MDB1. And then I have to tell it what the current master is, where I'm failing from. And in this case, my master is MDB4. All right, so let's run that. I got an OK. You can see almost immediately before I could even switch the tabs when it did the OK, my master is now MariaDB 1. Okay, so now let's see what happened to that Java. You can see we're back to the basic configuration where I'm writing to MariaDB 1 and reading from MariaDB 2. So let's get a little bit more complicated and go back to this GADBC connector failover, sequential failover here. So far, we've been doing all of this back and forth as we're playing with backend servers, and it's been connecting to that first MaxScale node, right? That first IP address that we have in the connection string. So what happens when that goes down? Now going back over here, all of that promotion and setting up, changing replicas and failover that's happening in the backend, that's all being performed by that primary node. And how I can tell that is that in the log, we'll see a cooperative lock. The cooperative lock is just a record in the backend servers that disappear when MaxScale is no longer connected to it. So when MaxScale 1 disappears, the cooperative lock disappears from those backend nodes. And MaxScale 2, who has been patiently waiting for that lock to be released, is able to acquire that cooperative lock. And once it does, it is now in charge of promotion and demotion. Okay, so when we scroll back in the logs and look at some of this failover more in detail, you can see that this MaxScale node 1 is the one that's selecting servers for promotion, right? Selecting server to promote and replace MariaDB 2, which we took offline when we took all 3 nodes offline. And in this case, it selected MariaDB 4, right? All of that action is happening on this MaxScale 1. So when we look at MaxScale 2 logs for the same time period, we see that it also recognizes that MariaDB 2 is not a valid master because it doesn't have the cooperative lock at the moment. It's not going to do anything else but passively monitor what's going on with those backend servers and determine where reads and writes should go. Okay, but it's not going to do any action. It's not going to perform any action on those backend servers. And why that is because MaxScale 2 doesn't have that cooperative lock in the backend. MaxScale 1 does. So let's show what happens when that changes. Let's take MaxScale 1 offline. Just like pulling the plug. I'll stop the MaxScale 1 instance. The only thing that goes into the log on MaxScale 2 is this little notice saying that MaxScale 2, this node was able to acquire the exclusive lock on a majority of its servers. Configuration automatic cluster manipulation operations, IG failover, can be performed in 5 monitor ticks. So that's saying that it's taking charge of all failover. Let's take MariaDB offline as well, MariaDB 1. You can see here my warning says that in 4 monitor ticks failover will begin, and it did that without MariaDB 1. So there's none of this changing of passive and active MaxScale servers. They're both always active. They're both always getting reads and writes through them. But the difference here is that only one of them will be able to perform failover actions, those cluster management actions, so that they don't conflict. And they will understand that between the two of them when you have cooperative monitoring configured. So bringing that MariaDB back online, MariaDB 1 back online, MaxScale 2 did it flawlessly without the need for MaxScale 1 to be online or any manual intervention there. So while I have MaxScale 1 in a stop state, let's see what happens with our script. Even though that first IP address was down, I was able to connect to that second IP address on MaxScale 2. My record was written to the table with the MariaDB 2 node, which is currently still master, right? And all of these records were read from MariaDB 1 node, which is my primary replica at the moment. So now I'm going to bring MaxScale 1 back online just so you can see that it won't conflict. It won't take a cooperative block because MaxScale 2 already has it. Now that my MaxScale 1 node is back online and accessible, I can see the startup log. So once it was able to successfully connect to all 4 servers, it started up the listening service, configured the states correctly. But you'll see, and we'll continue to tail that, you'll see it never tried to take that cooperative lock from MaxScale 2. So one more time with MaxScale 1 back online, let's run that script again. And make sure that we're able to connect in the same way. Now that MaxScale 1 was back online, it was able to successfully connect to that first IP address and insert the record via our primary node, MariaDB 2, and read all these records from the MariaDB 1 node. So there it is, a condensed demonstration of high availability with MaxScale, cooperative locking, and automatic failover.